Okay, I promise this is the last time I'm writing in black here. But it's just an outline of what is supposed to be today's class. Okay, so let's talk a little bit about fairness in economics. I asked you in the end of the previous section, we found an allocation there, we found the allocation was competitive, but I asked, is this allocation fair? And I don't know. Actually, I asked you to think a little bit about this. And what do we mean? This is not a rhetorical question. Let's see if you have something to add. What would be an allocation to be fair? What does it mean? Communist society is one possibility of fairness. Everyone has another one. I'm saying fairness, and I want to leave it like that. Well, the truth is, economists, most of the times, we deviate. We don't talk very much about fairness. You know, we say, oh, that's efficient, that's competitive, there's profits in there. But we don't answer this question, what is fair in economics language. If you take in philosophy classes, there's a huge, it's a really huge topic in philosophy. Fairness, what is ethics. It's a traditional topic in philosophy. We talk economists, we tend to deviate from this question. So if you decide to go to law school for some reason in your life, you're going to talk a lot about fairness. But we do have some concepts of fairness, and we have a little to say about fairness. Okay? So I'm going to first say a little bit of possible different interpretations of what we understand an allocation should be fair. So, bad English, the idea is there. So, the first interpretation, what's your name again? Gibson? Gibson. The first interpretation, Gibson gives here, like, one possible means like, allocation to be fair is like, some sort of allocation. Everyone gets the same. It's one possibility. Has anyone here in this room ever heard about John Rawls? Nope. Oh, this doesn't matter. Okay, John Rawls was a professor in Harvard from law school. He died a few years ago. And he came with the Rawls criteria of justice, with the theory of justice of John Rawls. And he says a society that is just, a society that is fair, is a society that maximizes the utility of the worst person. The worst person, I mean the person of the worst possible utility gets the highest possible. It's a little bit mathematically complicated if you think about it, right? But if you have, for example, if you imagine societies where the most poor of all individuals is better off, that will be the most fair society. This is, if you think of countries a little bit like Sweden, where even the very, 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 very poor are still not doing so poorly, so Sweden will be a more fair society than the United States, where some people are really, really wealthy, but some people are poor. Not close to poor. So this would be Rawls' criteria of justice. He was a very influential professor in philosophy in the 20th century. It's very cool in law school. So. There's another possibility of understanding society to be fair. Another one that is very simple in economic terms is that allocation to be envy-free. It's not exactly like socialist one. Well, socialist one is envy-free because everyone has the same. But it could be better off than a socialist one. It's okay that Gibson and I end up having different allocations. Maybe he likes more cookies and I like more milk. So we're okay changing. We start at the same location, but we change a little bit. Say, oh, would you like, I'll give you 2 cookies, and you give me a little of milk. And he says, okay, fine. And in the end, he has his allocation, he's happy. I have my allocation, I am happy, and it's envy-free. I'm not envious. I'm not envious of his allocation, and he's not envious of mine. Look, this is more like an introductory topic. I just want to give you guys some different views of what else out there talking about. What's out there talking about fairness. There are different interpretations about it. Okay, I don't want you guys to memorize and go into detail about those things. It's just like to increase the interest in the topic. So, just to have an idea of how powerful some of the tools of game theory and microeconomics are, has anyone here heard about Professor Aumann? Robert Aumann. Okay, I decided to tell this just because Robert Aumann is my favorite economist alive. He writes amazing papers. So Aumann is this now really old Orthodox Jewish, has a really long beard, and he writes some really deep mathematical results. And he won the Nobel Prize in economics in 2005. But one of the things that he did that was kind of notorious is not the reason why he won the Nobel Prize. He won the Nobel Prize for other stuff. But one of the reasons that he did, there is, in the Jewish tradition, they have the Jewish law, the Talmud, which is a historical interpretation that they had of the Bible, and they tell you how the law should be run. So they had a puzzle there, a way to divide a state. In the case there is an inheritance, and people have different claims over this state. Let's say I have a state, and I died, and now I went bankrupt, I didn't have enough money, and I have different people claiming different shares of this state. It's kind of really old problem they have there. And they had in the Talmud the solution of how they should split the state into the people who own claims about it. But the only thing that happens is that they have this problem in the Talmud there, this table for two cases, like if the total claim is 100 and the state, there's one claim of 100 and the other claim of 150, but the state total value is 200, this is how we should divide it. And they have two cases for that. And for 2,000 years, Jewish scholars couldn't figure it out. How would be the case, how they would have to share a estate or inheritance for people if there were different cases than the children were there in the Talmud. So Ahmad went there, this really old professor, and he came to a paper, a Journal of Economic Theory in '85, when he kind of find what is the mathematical rule behind the logics in the Talmud, and he says, look, for all different cases, 2,000 years of people trying to solve, for all different cases, just apply this law. And this is going to solve. And then he uses some other examples from the Jewish Bible to say that this was actually what they thought about. And this is just something that he did all of his time. I just put it here to see. And in the introduction, he has to please people who are not like scholars of the Talmud, to say that, no, look, it doesn't mean that we here are smarter than anyone else that has tried to interpret this before. The only reason why we managed to do this is because we had the tools to figure out the rules behind the Talmud, is because we had the tools of modern game theory. And these allow me to solve for this problem. It's kind of a nice of an application of what people do. The almond rule. The paper that, not the mathematical one, but the other one that he wrote to explain this. I'm going to put it in the website so you guys can take a look if you like. Let's think about this for a while. Let's think about the socialist proposal. Is it efficient? Idea? Is it efficient? Why not? We're not using history here. This is a course of theory. One another or a theoretical. We are getting closer there. Contributions. No, but that doesn't violate our thing for efficiency, right? Let's say I'm the total dictator of a country. I am the king of the name. I'm sorry for this. I'm the king of Brunei, I do nothing for the economy, and I own all the money. That's efficient. Right? Yes. We're not talking about efficiency. I'm still talking about a very simple idea of efficiency that we had here. A society is efficient if its allocation is efficient if it's not dominated by another allocation. Let's try to think about in terms of that. Someone else raise a hand there? The idea why it's not necessarily efficient is because people can have different tastes. Right? They may like milk more than Gibson likes cookies. And I would like to have a different allocation. I could do better off. And if you allow us to exchange milk for cookies, we will both be better off. So that's not necessarily efficient. Rawls theory of justice, a first society maximizes the utility of the poorest of its individuals. Well, if two individuals, it's kind of trivial that this could be efficient. This could be efficient in many cases, sure. There are also some allocations that satisfy the Rawls theory of justice, and they are not efficient. But it's okay. That's a case that is closely related that we have our efficient. MV3 allocation. MV3 allocation, is it efficient? An allocation that is MV3, is it efficient? Let's think about it. Let's say Gibson and I we have milks and cookies. And I don't want to have his allocation, and he doesn't want to have mine. Does it mean that it is efficient? Well, let's think of the case that he has 0 of everything, and I have 0 of everything. But there's still 10 milks and 8 milks and 10 cooks out there. I don't want to have his 0. He doesn't want to have mine, but there's still a bunch of them that's left behind. We could both be better off. So that's not necessarily efficient. Oh, all non-equal division of contrast sums is efficient, but it only works for a very specific case when people already have claims over it. So yeah. So there are many ways of thinking about efficiency. And we are silent. We're not very loudly as economists about what is fairness. It's more a question of parameters and law as for now on, we're going to talk only about you can have any fairness criterion that you like. You may think that it's total equality of utility, but it's any level of any kind of fairness that you want, provided that this kind of level of fairness is efficient. Okay, so let's focus on fair allocation that are efficient. I'll put this in the board so you guys remember. So let's restrict ourselves to this fairness possible criteria. Okay. Any questions so far? It does seem to be puzzling. Okay. Let's go back to the example that we had in the previous class about Israel and Saladin and how they share their economy of cookies and milk. So now we have the same parameters as before, but now I'm giving numbers to the things. Okay, I'm not going to solve in terms of alpha, beta, W, and everything else. I'm saying that what was alpha now is 0.6, and what was beta now is 0.2. It means that like everything else equal, Saladin likes milk more than Gibraltar does. Oh, there's something wrong there. Oh, by now they have different wealths. So the wealth that every Saladin has is 2, and the wealth that every Gibraltar has is equal to 10. First question is, can you find out the prices in order to find an allocation in equilibrium? So we have done all the algebra in the previous class. I don't want to keep doing algebra here, all the same algebra over again. So I'm just going to use the results in the formulas that we had in the previous lecture. Any questions so far about the framework? So those are the formulas that we have put there in the previous lecture. Okay, we solve for this. If you don't know how to get this, it's probably on your notebook. Well, technically speaking, this is not a solution because the solution has to be the final allocation in terms of exogenous variables. But the prices here are endogenous variables. So we have another equation for the prices. Okay, and now it's just a game of plugging all the parameters you have here. Alpha is equal to 0.6. 0.6, 2, 0.4, something more. This is bigger. Beta is 0.8. And just plugging all the parameters that we have there, we're going to figure out where the price is and what is the final location. So, just used a bunch of equations that we had from the previous class, and we figured out where are the locations and where are the prices. At least it sounds intuitive to me that well, Gibraltar gets way more cookies than Saladin, which unsurprisingly, because first of all, Gibraltar likes cookies way more than Saladin, because Gibraltar likes cookies 0.8 and Saladin 0.4. Moreover, Gibraltar is way wealthier than Saladin here. He has 5 times the income of Saladin. So it's okay. And I guess his share of milk is true. He gets 5 of each. 5 milk, while Saladin gets 3. Well, that's what happens when you're poor. Even though Saladin likes milk more than Gibraltar does. This is a location there. Yes? Why do you say it's spherical? Well, the thing there is like under Rawls' criterion of fairness, probably not, because I can make Saladin better off by stealing some of the things from Gibraltar. Yeah, that's it. I could like take away from Gibraltar and give to Saladin, and that's what? Like robbing the star. We're going to talk about it. But under that condition, no. Under Rawls' criterion, no. Is it envy-free? Envy-free, we can tell whether it's envy-free or not. I forgot. Kevin? Right. Is it envy-free?
Are we going to like substitute both of their allocations together and get more of like
I don't see what you said.
I mean, you mentioned that Saladin's poor, but he does like milk more, right?
Yeah.
So if you get more milk, he's happy, right?
Yeah, and it's like, to check whether something is envy-free is like this. Would Saladin prefer to have Gibraltar's allocation? Yeah, Gibraltar has more of everything. No, Gibraltar doesn't want to have Saladin's allocation, but Saladin wants to. It's not envy-free, it's envy in society. So it's not NV3. Well, the thing is, we don't know. In order to answer whether this is fair or not, we have to stipulate a criteria of fairness. Okay? I'm going to stipulate one criteria of fairness here now, and then I'm going to work on this criteria of fairness. I'm going to say, let's say we look and say, we don't care what happens with cookies. But milk is something important in society. A fair society, everyone must have 4 liters of milk. Okay? So we just have this ad hoc criterion that we came up here right now, and this is the criteria we are going to adopt. So in this case, is the total endowment of milk. It's 8. It means that we want both of them to have 4. I'm going to put a heart here. It means that it's fair. Following question. What is the efficient allocation in which they both have 4? Four liters of milk. Okay, better than that. I don't expect you guys to be able to solve this in your head. I expect you guys to be able to know how to calculate. I'm in no conditions at all to think. After making my movie yesterday, my arms were pretty sore. And after yelling in the Brazil game, basically not this. But let's try. So how do we get the efficient allocation where milk of each is equal to 4? What characterizes an allocation to be efficient? I remember this was mentioned here when you were talking about, remember the Edwards box? Remember what was an efficient allocation there? What does it mean? How do we get to the contract curve, where the set of points where the efficient allocations lie? what characterizes this curve here? Where is the peculiarity of this curve? How did we get it? Yes, this is how we got to this. This is the point where all the different curves. So the different curves are tangent to each other. Another way to represent this was very briefly mentioned, so I'm okay if you guys are remembering. It's the different curves being tangent to each other means that the marginal rate of substitution is the same. So everywhere here, everywhere in curve, the marginal rate of substitution of Saladin is equal to the marginal rate of substitution of Gilbert. And what is, if you don't remember, what is the marginal rate of substitution? It's just the ratio of the marginal utilities, of the partial derivative of each, of the partial derivative of the utility taken with respect to each of the inputs of the utility. So we take this utility here, the utility of Saladin, and we differentiate. So the marginal rate of substitution of Saladin is differentiating his utility with respect to MS. I differentiate his utility with respect to MS. Now I'm going to differentiate his utility with respect to CS. Okay, this is the marginal utility, the ratio of the marginal utilities. Just now cancel now and find some algebra. Okay, now I'm going to do the same thing of the marginal rate of substitution for Gibral. But Gibral doesn't have S here. He has G's everywhere. Okay. And now all I have to do is equalize both of these equations and find the allocation that we're looking for. generalizing this, so the efficient allocation but our fair criteria implies that each of them consumes 4 units of milk. So I'm going to replace the 4 units of milk here now. Okay? Yes, I did. For the what? I think so, but you want to know what this ratio is? Of the utility function. Okay? Okay, in case this is not clear. Marginal rate of substitution of saladin is equal to the derivative of the utility of saladin with respect to MS divided by the derivative of the utility of saladin divided by CS. Okay? And of Gibrel, the same thing. But for Gibrel. This is what MRS is. Method is right? Method.
How did you get 2.4 and 4.4?
It's 2 times 4.
Oh, that's what it is?
Well, this is not puzzle now. I want to talk about this. When I want to write something like 0.8 times 6, how do I write? I have to use the cross? Let's just see. Seriously, this is how you write in English. Because when I come from like dot, comma, we use comma. So I was thinking about this. I was looking through my notes and said, how do you write this thing? Do I have to put a parenthesis there?
I think instead of putting the parentheses, just put the parentheses at where before. That's pretty
Yeah, it's like, I'm not judging you. I'm judging the whole grammar, the English grammar. In my notes, I'm like puzzled because I'm 0.2.4 in my notes. With my background. Okay, so this is how I got the 2 times 4. So cancel. So now, how do we solve? How do we solve for this now? What haven't we done? What? Process? Prices. No, because allocation, when it's prices or the decentralized economy, an allocation does not need prices. Or something? Would you like to join the discussion? Which equation here? We're trying to solve. So we know the milk for Gibrel, milk for Saladin equals 4. And we're trying to figure out what is the amount of cookies that each of them has is going to have in this efficient allocation. But there we have one equation and two unknowns. It says that we are missing one equation. Which equation we still have to use that we haven't used? The resource equation. Thank you. We also know what else? We have for the resource constraint that they have to add to 10. So basically we have that CS equals to 10 minus CG. Or the other way around. I'm going to replace this back here. So this implies the 3, actually it just has to cross 6 CS is equal to 6 CS equals to 10 minus CS, which implies the CS is equal to 10 minus 7. And 10 divided by 7, 1.42. And also, this implies CG is equal to 10 minus 10 divided by 7, which is 6 divided by 7. Right? Okay. So this is the Faraday equation. We have established our Faraday rule that means that each of them gets 4. And now we have to figure out what we're going to get with cookies. Well, it means that Gibraltar has to get way more cookies than Saladin because he likes cookies way more than Saladin. Okay? So if he has this amount of cookies, he doesn't want to trade with Saladin in the end. I said, I'm fine. I'm satisfied with 4 milks and 4 liters of milk and 8.58 cookies. Well, so far it was just like finding what is the fair allocation. But we, as economists, we're not satisfied with simply figuring out, oh, what is efficient, what is fair. We want to put our nose on policy. And we want to improve society, so we would like to recommend something. We would like to prescribe a policy intervention. So, how do you guys propose we attain this efficient allocation? How should we get to there? You may think this is silly. Oh, I think milk example is not that silly because many societies think that kids and people, they must have at least a certain amount of milk per week to consume. And if they don't have, they are below the acceptable levels. But if you think about it, this could be other thing. It could be healthcare. Okay, everyone has some discussion that is present in slightly in this country. Is that like people should have a minimum amount of healthcare, and we don't consider a society where people don't have this minimum amount of healthcare fair. In this case here, in our micro society, it's milk. Like people must have 4 liters of milk, otherwise we don't consider it's fair. Very good. We figure out what is a fair allocation. Now, how do we get to that? Any suggestions? Right. Well, can manipulate prices. Let's start with that. I like this as my example. So let's manipulate prices. This was the idea Right. So let's just try to figure out what is the reverse engineering in our mind. Okay? So we want to get the prices such that Saladin gets 4. Right? We have the equation for prices there. We know how, we have the equation for the demand of Saladin there. So all we need is a price such that Saladin gets 4. So the milk the Saladin gets must be equal to 4. And we know that's equal to 4. And that means we know that what he gets is alpha times WS divided by